Cheen tapak dum dum.
For such coding related videos, subscribe to Code with AG. Hello coders, welcome to Code with AG. Here we meet again. I hope all you are doing good with your coding skills. So we have met today on a medium tag question, which is find the prefix common array of two arrays. So you are given two zero-indexed integer permutation a and b of length n. Like there is a length n, there's a length n, and we have given two permutations of the length n. Like if n equals to 4, so we have given two permutations of 4, like 1, 2, 3, 4, or 4, 2, 3. 4, 3, 2, 1. These are the permutations. We can also write it 4, 2, 3, 1 or 4, 1, 3, 2. These are all the permutations of the array. A prefix common array of A and B is the array C such that Ci is equal to the count of the numbers that are present at or before the index I in both A and B. Like when we are traversing we have to find the common array C, which is formed by traversing both the array simultaneously and finding out the number of common elements we have found till far. Like for our let's suppose we take these we take 1 2 3 4 and 4 2 3 1 as the array. So let's take the C array. Let's take C array. This is the answer array. So we have found 1 and 4, no common. We have found 2 or 2. We have, for this, no common, 0. For this, 2 2, only 1 common. 3 3, 2 common, because 2 2 is also there, 3 3 is also there, and 4 1. We have found all 4. We have found all 4 because 1 is also there, 4 is also there, 2 is also there, 3 is also there. So we found 4. So this is the answer. We have to return this array. Okay. So let's see the examples. What are the examples? First example is 1 3 2 4 and B is 3 1 2 4. So let's make a answer array. So for first case, 1 and 3, nothing is in common. For the second thing, 3 1. So there are two elements in common, 3 and 1. So 2. So first is 0, second is 2. Third is 2 and 2. We have find 3 elements in common. 2 and 2. We have find 3 elements in common. And in the next one, 4 elements in common. So this is our array. For this also, we have, for the first element, we have find nothing in common, 0. For the second one, we have found only 1 in common. For the third element, we have found all 3. This is the final array. So we have to just find these array. So after looking at the question, what do you think? What approaches can we follow? What data structure can we use? I think we can use a map and a bit mask. I will show you both the techniques to solve this particular question. Okay. So for the first example, using map. It is clear from here. That the count of each element can be maximum of 2. Like if we have to find for 3, the 3 can be only here or here, one here. So maximum can be 2. So we have make a map and traversing one by one. For I equals to 0, first of all we keep map of 1 equals to 1, and then we will take a count pointer count pointer. We will check that map of 1 equals, if it is equals to 2, if it is equals to 2, like it has occurred previously before, and now we have incremented, so we have found it the common element. We have found it as a common element. So we will increment it in the count. We will increment it in the count. So no, this is not 2. Okay. Then we will add for this 3. For this 3, we have to check for both index separately. We have to check for the both index of the array separately. For both array separately. So MP of 3 equals to 1. Now, is this equals to 2? No. Now, for MP of, for this index, MP of 3, we have incremented 2. So now it is equals to 2? Yes. So we will add. It means MP of 3 has occurred before, and now it has occurred again as a common element. Now MP of 1, we have to increment. Now it is equals to 2? Yes. So we will increment the count. And after each loop, like for that first index, we haven't incremented anything. So we will push that value in our count. Now in this loop, we have incremented 2 times, so 2. Now when we iterate again, here MP of 2 equals to 1. MP of 2 equals to 1. Is it equals to 2? No, we will not increment 2. Now for this element, MP of 2, we will increment it. It is 2. Now it is equals to 2? Yes. So we will increment count. Okay. Now the loop is over. So 3. Now for the next iteration, it is 4. MP of 4 equals to 1, not equals to 2. So not incrementing the count. Now for this also, for this index in the B, we will increment MP of 4 to, it is equals to 2. We will increment 4. We will increment it to 4. Now 4 will be added to the array. So this will be the array. Okay. Let's check for this example also. 2, 3, 1. And what was the 3, 1, 2. Okay. This is a map. This is a vector. And we have a count variable equals to 0. Now map for this first indexes in both array. So map of 2 equal को हमने increment किया. Map of 2 को we will increment. And is this equals to 2? No, it's not equals to 2. We will not increment count. Now map for this index, for this array, map of 3 equals to 1. Is this equals to 2? No, this is not equals to 2. Not incrementing count. Now this index is over. We will push this count value in our array 0. Okay. For the next index, MP of 3. If this equals MP of 3, we will increment. Is this equals to 2? Yes, it is equals to 2. We will increment our count. Now MP of 1. Is this equals to 2? No. Is this equals to 2? No. So no increment. So this index is also over. We will push it into the vector. Now MP of 1. We will increment. Is this equals to 2? Yes, it is equals to 2. MP of 2. We will increment here. Is this equals to 2? Yes, it is equals to 2. We will increment count. Now we will push it into the vector. So this is our final vector. Okay. So this is our question. We will firstly implement the question. So let's make a solution vector. Make a map and also initialize a count vector. Okay. Now make a loop. to traverse each and every element. Traverse each and every element. Now, firstly, we will implement all the character of A. Firstly, we will implement the character of A. Now, if this value in map A, this value in map is equals to 2, we will increment our counter. Okay. Now we will do this same thing for our value at that index in vector B. And then also check the value at that map. Then also check the value at the map. The iteration is complete. We will push this count value in our solution vector. Okay. And we will return solution. I hope this is clear. Oh, this will not execute. Push back. Okay. So I think it is accepting completely. Now we will check another approach. We will check another approach to solve the question, which is bit masking, which is bit manipulation. First of all, why we will use this approach over this approach? Because this approach can reduce the space complexity. Here we are using a map. And in this condition, and map will be taking the how much space? Map will be taking big O of n space. But in bit manipulation, this will not be the case. I am showing how you can execute the question. Like 2, 3, 1, which was the example, and 3, 1, 2. Okay. Now we will take two variables A and B. First of all, if we have to mark that we have found the element, what things can we do? What things can we do? We can make, if we have find two, let's suppose if we find 1, we have make this mark. If we find 2, this mark. If we find 3, this mark. It means the position at which 1 will come is equals to the count of that number. 1, 2, 3. 1, 2. This is 2. And if we find 4, 1, 2, 3. This is no. So at the fourth position we have find 1. At the fourth position we have find 1. At the fifth position we have find 1. This is 5. This is 4. This is 3. This is 2. This is 1. This is 1. Okay. So let's suppose traverse one by one all the elements for this one. Let's suppose we have only one. We will traverse it 2 times. So what will happen? This is equals to 3. So we don't need to traverse it 2 times. We can only traverse it n minus 1, which is 2 minus 1. 2 minus 1 is 1. So it is equals to 1, 0. 1, 0 is equals to 2. It means we have found 2. So this is, let's suppose we have this number. We can OR it with 0. So if we OR it, it will become 1, 0. It will become 1, 0. Okay. It means we have found 2 number. We have find number 2. If we have got answer like this, 1, 1. What does this mean? This doesn't mean 3. It means we have find number 2 and we have found number 1. Okay, so this is the question. This is how we are dealing with this question. This is how we are dealing with this question. So here a equals to 1 0. Here a is equals to 1 0. Let me erase it. Here a is equals to 1 0. Okay, here now a equals to 1 0. Now for the b, okay, for this index we will left shift it to 3 minus 1. 3 minus 1 is 2, so it will become 1 0 0, because it will shift, it will shift to left side and give us 0 in the right side. It means we have found a 3. Now we will OR it will b. The b is this. Okay, so we have found this. Okay, so what does this scenario means? We have found a 2 in A and a 3 in B. Now we have to find the common elements. Common element, how can we find out? Using AND. Now we can AND both of these, 1 0 0 and 1 0. So it will be 0 0 0. Means no common element. If we have found, like suppose this will be also like this. If this was this, so this will be 1 0 0. It means we have found a common element which is 3. But here we are not finding any common element. So we have to check in that AND factor that how many ones we are finding. So here we are 0 0 0. Here we found it as, so what was this? 1 0 and 1 0 0. So it is 0 0 0. So there is no one. We will take a answer vector. No one. So 0. Okay. Now traversing for the next index. We will left shift it to 3 minus 1, which is 2. So this will give us 1 0 0. Now we will OR it with A. So when we will, A is equals to 1 0. A is equals to 0 1 0 1 1 0. So what does this mean? That A has founded 3 as well as 2. So what will A become? 1 1 0. Okay. Now for B. We will left shift it to 1 minus 0. 1 minus 1, which is 0. So the answer will be 1. Now we will OR it with B. So the answer will become 1 0 1. It means we have found it 3 and 1. Now we will check the number of ones occurring in the AND of both. Number of ones in the AND of both. So what is the AND of these? 1 1 0 and 1 0 1. AND of these are 1 0. Number of ones occurring is 1, and which means that only 3 is the number which is common between both. Now for the next element, for this index, we will increment 1 by 1 mod 1 left shift. 1 minus 1, which is 0, which gives us 1. We will OR it with A. So it will become 1 1 1. Okay. And for this element 2, we will left shift 1 with 2 minus 1, which is 1, which will give 1 0, which will give us 1 0. Okay. Now we will AND it with one with the element in B. So this will give 1 1 1. This will give 1 1 1. Okay. Now we will add both of these 1 1 1 and 1 1 1 gives 1 1 1. So how many numbers? How many ones are there? 3. 3 ones. So this is our final array. This is our final array. Okay. This is our final array. So we have found it 3 ones. So this can also be a bit masking and a good approach because we are not using extra space. Extra space. Map is using. Okay. This will reduce the time. This will also reduce the time. So I hope these two approaches are very much clear to you. If you like the video, please give a big thumbs up, like, subscribe and share. And please, if you guys have any doubts in any of the part of this video, please comment down. I will love to read all the comments. Thank you.